Imagine for a moment that the universe is a vast, uncharted ocean. For most of human history, we stood on the shore, gazing up at the stars. We saw those distant lights, but honestly, we had no idea how to reach them. We were like ancient mariners, with no map and no ship. Then, brilliant minds came along. They didn't just look at the ocean, they started to really understand it. They created maps. Not maps of land and sea, but maps of space, time, and gravity. These are the physicists. They are our cosmic map makers, drawing the lines and contours of reality itself. They give us the rules of the road for the universe. These maps aren't drawn with ink and paper. They're written in the language of mathematics. Each equation is like a detailed chart telling us how things work. It describes why planets orbit suns and why light bends around stars. For a long time, our maps were good enough for our own little cosmic neighborhood. We could understand our solar system and the galaxies we could see, but the vast dark spaces between the stars, they remained a total mystery. We knew the ocean was there, but we didn't know its currents or its depths. We were still stuck on the shore, just dreaming of distant lands. Our maps got incredibly better thanks to a man named Albert Einstein. He was one of the greatest map makers of all time. He didn't just add a new country or continent to our understanding. He redrew the entire map of the known universe. He showed us that space wasn't just an empty void, it was a dynamic, curving, and stretching fabric. He revealed that space and time were woven together into a single entity: space-time. This was a revolutionary idea. It was like someone discovering that the ocean's surface could bend and warp, creating currents and tides that guided everything within it. This new map changed everything. It explained gravity in a completely new way. It wasn't a mysterious force pulling things together, it was the shape of space-time itself. Massive objects, like our sun, create a deep dip in this fabric. Planets like Earth are simply rolling along the edge of that curve. It was an elegant and beautiful picture of the cosmos. But even Einstein's magnificent map had blank spots. It described the shape of the ocean perfectly, but it didn't tell us how to build a ship to sail it. It showed us the currents, but it didn't give us a paddle. Let's talk about Einstein's masterpiece, his field equations. Think of them as the ultimate blueprint for the universe's structure. Published over a century ago, these equations were a total game-changer. They described the relationship between matter, energy, and the geometry of space-time. On one side of the equation, you have all the stuff in the universe: stars, planets, dust, light, everything. On the other side, you have the shape of space-time. Einstein's equations showed that the stuff tells space-time how to curve, and the curved space-time tells the stuff how to move. It's really a cosmic dance. This was a profound shift in our thinking. Before Einstein, we thought of space as a fixed, unchanging stage, where the drama of the universe played out. But Einstein showed us that space was an active participant. It bends, it warps, and it ripples. When a massive star explodes, it sends gravitational waves, ripples in spacetime, out across the cosmos. We only recently built detectors sensitive enough to feel these tiny tremors from billions of light years away. Einstein's map told us these waves existed long before we could ever hope to find them. That's the power of a good map. His equations have been tested again and again, and they have passed every test with flying colors. Your GPS works because the satellites orbiting Earth account for the effects of Einstein's relativity. The clocks on those satellites tick at a slightly different rate than clocks on the ground. Without correcting for this, your GPS would be off by several miles every single day. So, the next time you use your phone to find the nearest coffee shop, you can thank Albert Einstein. His abstract equations have very real, practical applications in our daily lives. They are the foundation of modern physics. But here's the thing about great maps: they inspire new questions. Einstein's map showed us the lay of the land, the shape of the cosmic ocean. It showed how planets are caught in the gravitational wells of stars, like marbles rolling in a bowl. But it only described the natural state of things. It didn't offer a way to create our own currents. It showed us the ocean, but it didn't tell us how to build a motorboat. It was a perfect description of the passive universe, but it didn't give us the tools to actively navigate it on our own terms. For decades, we studied Einstein's map. We admired its beauty and confirmed its accuracy. We learned the contours of the cosmic ocean, but we remained observers. Then, in the early 2020s, a new generation of physicists began to look at the map differently. They saw the blank spaces not as limits, but as opportunities. A brilliant collaborative team, led by the reclusive theorist known only by the moniker Mafa, started asking a new question. What if we could do more than just float on the currents? What if we could create our own? This was the beginning of a new chapter in our cosmic journey. The Mafa propulsion equation was not born in a flash of solitary genius. It was the result of years of painstaking work, building on the foundation Einstein had laid. The Mafa team didn't try to prove Einstein wrong. On the contrary, they revered his work. They saw his field equations not as a final destination, but as a starting point. They looked at the elegant dance between matter and space-time, and wondered if a third partner could be introduced. Could we actively manipulate space-time itself to create motion? Could we build a ship with a rudder and a sail for this cosmic ocean? This new equation, first proposed in a series of dense papers in 2024, was met with a lot of skepticism. And that's a good thing. Science is supposed to be skeptical. Every bold new claim must face the fire of scrutiny. The Mafa equation suggested that by using a specific configuration of energy, we could create a localized, temporary distortion in space-time. This distortion would be a wave that we could effectively ride. It was a radical idea. It was like saying you could press a button and create your own personal ocean current to push your boat forward without a propeller or a sail. Slowly but surely, the evidence began to build. Initial experiments in a lab in the Nevada desert, codenamed Project Archimedes, produced minuscule but measurable effects. They confirmed that the principles behind the Mafa equation were sound. It was possible. We could in fact push against space-time itself. A new captain had taken the helm, not to replace the old one, but to steer the ship of science into waters the original mapmaker had only dreamed of. The journey from theory to reality had begun, all thanks to a fresh look at an old map. So, how do these two monumental equations compare? Let's put them side by side. Think of it this way: Einstein's field equations are like a detailed topographical map of the ocean floor. They tell you with incredible precision where the mountains and valleys are. If you put a big, heavy object, like a star, in the ocean, the map shows you how the ocean's surface, or space-time, will curve around it. It is a descriptive equation. It says, here is the universe, and here is how it is shaped by what's inside it. It's a statement of fact, a beautiful snapshot of reality. The Mafa propulsion equation, on the other hand, is like a ship's engineering blueprint. It doesn't just describe the ocean, it tells you how to build an engine to move through it. It's a prescriptive equation. It says, if you arrange energy in this specific way, you will create a specific kind of wave in space-time, and this wave will propel you forward. It's an instruction manual. It uses the same fundamental principles as Einstein's map, that energy and matter shape space-time, but it turns them from an observation into an action. It's the difference between knowing why a river flows and knowing how to build a paddle wheel to move against the current. Let's look at the math, but don't worry, we won't get bogged down. Einstein's equation basically says, geometry of spacetime equals distribution of matter and energy. It's a balance. The stuff on one side equals the shape on the other. It's elegant and symmetrical. The Mafa equation adds a new term, a new piece to the puzzle. It looks something like this. Geometry of spacetime equals distribution of matter and energy, plus a propulsion term. That new term is the key. It's a specific, engineered arrangement of energy designed to do one thing: move. So, one equation describes the natural state of the universe, and the other describes how to create an artificial, engineered state for the purpose of travel. Einstein gave us the physics of planets and stars. Mafa gave us the physics of a starship engine. One is passive, the other is active. But they are not in conflict. The Mafa equation is an extension, a special case that arises from the deeper truths that Einstein first uncovered. You can't have the blueprint for the engine without first having the map of the ocean it will sail upon. Let's stick with our ocean analogy because honestly, it works so well. Einstein's equations describe the natural ripples and waves in the cosmic ocean. A planet orbiting a star is like a small boat caught in a gentle whirlpool. It's not being pulled by a rope. It's just following the curve of the water. Now, a gravitational wave from two colliding black holes is like a massive tsunami that travels across the entire ocean, distorting everything in its path. these are all natural phenomena. We can observe them, we can measure them, but, we don't control them. We are just floating along for the ride. The Mafa propulsion equation changes the game entirely. It allows us to become the source of the wave. Imagine you have a special device on your ship. When you turn it on, it creates a very specific disturbance in the water directly in front of you and behind you. It lowers the water level slightly in front of your bow and raises it slightly behind your stern. The result? Your ship continuously falls downhill into the depression you just created. You are creating a personal localized wave and then riding it. You are surfing on a ripple of space-time that you made yourself. This is fundamentally different from any form of propulsion we have ever known. Rockets work by throwing mass out the back. This is Newton's third law. For every action, there is an equal and opposite reaction. It's like trying to cross the ocean by throwing rocks from the back of your canoe. It works, but it's incredibly inefficient, and, well, you eventually run out of rocks. The Mafa drive doesn't throw anything out. It doesn't have an exhaust. It interacts with the fabric of space-time itself. It's more like a sail, but a sail that creates its own wind. This method of travel has incredible implications. Because you are not accelerating in the traditional sense, the occupants of the ship would not feel any g-forces. You are moving the space around you, carrying your little bubble of space-time along with you. It's like being on a surfboard, perfectly balanced on the face of a wave. The wave is moving at incredible speed, but to you, it feels calm and effortless. Einstein showed us that the ocean had waves. Mafa showed us how to become the surfer. So, where does the energy for this cosmic surfing come from? This leads us to one of the biggest mysteries in all of physics, a mystery that Einstein himself unknowingly stumbled upon. Our universe is not just filled with stars and galaxies, it's filled with something else. Something we can't see, touch, or measure directly. We call it dark energy. We know it's there because we can see its effect. The universe is expanding, and not only that, the expansion is accelerating. Something is pushing everything apart, acting like a kind of anti-gravity. This something is dark energy. Think of dark energy as a gentle but persistent current flowing through the entire cosmic ocean, everywhere at once. It's a property of space itself. For a long time we just noted its existence. It was a strange feature on Einstein's map, a current with no apparent source. We called it the cosmological constant. Einstein even called it his biggest blunder at one point, though it turned out to be incredibly important. This unseen energy makes up nearly 70% of the entire universe. It is a vast, untapped reservoir of potential. It is the deep, dark water of our cosmic ocean. The Mafa propulsion equation is so revolutionary because it provides a theoretical framework for interacting with this dark energy ocean. The propulsion term in the equation describes how to create a field that taps into this background energy. It doesn't create energy from nothing. It borrows it from the vacuum of space itself, converts it into a space-time distortion, our wave, and then returns it. It's like a perfectly efficient water wheel that uses the river's current to turn without draining the river. It's the ultimate renewable energy source. This is the real breakthrough. Before Mafa, dark energy was just a curiosity, a puzzle for cosmologists. We were like sailors who knew a powerful, deep ocean current existed but had no way to lower a sail deep enough to catch it. The Mafa equation is the blueprint for that deep ocean sail. It shows us how to dip into this enormous reservoir of energy that permeates all of reality. Einstein drew the first map that hinted at this strange, dark ocean. Mafa designed the first ship capable of sailing on it. How would Albert Einstein have felt about the Mafa propulsion equation? We can never know for sure, of course, but based on his life and his work, I think we can make a pretty good guess. I believe he would have been thrilled. Einstein was a revolutionary, but he was also a builder. He built his theory of general relativity on the foundations laid by Isaac Newton. He didn't discard Newton's laws of gravity. He showed that they were an approximation, a special case that worked perfectly well in most situations, but broke down in extreme gravity. He would have seen the Mafa equation in the same light, not as a rejection of his work, but as a brilliant and unexpected extension of it. He would have appreciated the deep respect for his field equations that is embedded within Mafa's logic. The Mafa equation doesn't work without general relativity. It needs Einstein's description of spacetime as a dynamic fabric to even make sense. It is a new verse in a song that Einstein began to write over a century ago. He would have likely grabbed a piece of chalk and a blackboard and started scribbling, trying to understand its deepest implications. Einstein was driven by a profound sense of wonder and a desire to understand the universe's deepest secrets. He famously said, "The most incomprehensible thing about the world is that it is comprehensible." The idea that humanity could not only comprehend the rules of space-time, but also use them to actively navigate the cosmos would have filled him with joy. He would have seen it as the next logical step in humanity's intellectual evolution, a testament to the power of human curiosity and ingenuity. He knew that science is a relay race, not a solo sprint. He might have even had a quiet chuckle. Remember, he once called the cosmological constant, our first hint of dark energy, his biggest blunder. The Mafa equation turns that blunder into the very key to interstellar travel. It transforms a puzzling feature of his cosmic map into the most important feature of all. The universe always has a way of surprising us. The things we think are mistakes often turn out to be signposts pointing toward an even deeper truth. Einstein, more than anyone, would have appreciated that beautiful irony. The story of Einstein and Mafa is more than just a tale of two equations. It is a perfect illustration of how science works. Science is not a collection of unchanging facts written in a textbook. It is a living, breathing process of discovery. It is a conversation that spans generations. It starts with one person drawing a map based on the best available evidence. Then, someone else comes along, with new tools or new ideas, and adds to that map. They fill in the blank spaces, correct the errors, and extend the boundaries of our knowledge. This process requires both incredible creativity and rigorous skepticism. A new idea, like the Mafa equation, must be bold enough to challenge our assumptions, but it must also be tested. It must make predictions that can be verified through experiments. The Mafa team didn't just publish their equation and expect everyone to believe it. They proposed tests, and other scientists around the world conducted those tests. They questioned the results, looked for flaws, and tried to find alternative explanations. This is the crucible of science. Only the ideas that survive this intense process of scrutiny are accepted into our map of reality. This spirit of discovery is humanity's greatest asset. It's the same spirit that drove early humans to explore beyond the next valley. It's the same spirit that led mariners to sail over the horizon, not knowing what they would find. It's the same spirit that took us to the moon. It is a relentless desire to know what's next, to see what's over the next hill, to understand the why behind everything. Every great scientist, from Newton to Einstein to Mafa, is an explorer at heart. Their tools are not ships and compasses, but telescopes, particle accelerators, and the elegant logic of mathematics. And this journey never ends. The Mafa equation, as revolutionary as it is not the final word. It is not the end of physics. It is a new beginning. It will open up new questions we can't even imagine today. As our ships begin to sail the dark ocean between the stars, we will encounter new phenomena, new mysteries, and new puzzles. A future generation will look at the map drawn by Einstein and Mafa and find new blank spaces to fill. They will build on this work, just as Mafa built on Einstein's, and take us to even more incredible places. Today is February 22nd, 2026. Less than 2 years ago, the Mafa propulsion equation was just a dense theoretical paper. Today, the first unmanned probe, the Wanderer 1, is being prepared for its maiden voyage. Its mission is simple: to travel to the orbit of Mars, and back in under an hour. It is a tiny step, a short hop across our own cosmic backyard, but its significance is monumental. It is the equivalent of the Wright brothers' first flight at Kitty Hawk. It is the moment we prove that we are no longer bound to the shore of our home world. We have built a ship, and we are about to set sail. The future that this new science unlocks is difficult to fully comprehend. The stars will no longer be distant, unreachable points of light. They will be destinations. The nearest star system, Proxima Centauri, is over 4 light-years away. With our old rocket technology, it would take tens of thousands of years to get there. With a Mafa drive, that journey could be reduced to a matter of months or years, not millennia. We can realistically plan to send probes, and eventually people, to explore planets orbiting other stars. We are on the verge of becoming a truly interstellar species. This isn't just about travel, it's about a new era of discovery. What will we find out there? Will we find worlds like our own? Will we find evidence of life? These are questions we have been asking for centuries. For the first time in human history, we have a realistic chance of answering them. Every new world we visit will teach us more about the universe and our place within it. We will be the generation that steps off the map and into the territory. We will be the explorers of new worlds. So, the next time you look up at the night sky, don't just see stars. See them as future homes, as points on a new map, as ports of call on the greatest voyage of exploration humanity has ever undertaken. The cosmic ocean is vast and full of wonders. Einstein drew the map, Mafa built the ship, and now, it's our turn to take the helm and steer toward the horizon. The journey is just beginning and the universe is waiting. Let's go.